Hello there. Today we'll be doing number of fractions that sum to 1. So in this particular problem, we are given a list of fractions where each list contains numerators and denominators, which represents the number of numerators, the number of the number numerator divided by a denominator. Return the number of pairs of fractions that are summed to 1. So given this particular set of fractions, or a list of fractions, we could create a output of 5 because 1 and 3/4 is 1, 2/5 and 3/5 is 1, 5/10 and 1/2 is 1, 5/10 and another 1/2 is 1, and 1/2 and 1/2 is 1. So I'm thinking a lot right now about the problem, what the sum problem, which basically means using a set to store all the numbers that we have seen. And then with that, we can use the counter part to check if that's inside our scene. And if it is, we need to increase our count by 1. However, with this particular problem, we can see that there are multiple items. And if we see multiple items, I think we need to add it twice. So this adds added to these two numbers, this number and this number. So we need to add 2. So we're going to have to increment the scene numbers. That means we have to use a dictionary to hold that information as a key to a value pair. We can't just say, oh, we've seen it, it exists, that's good enough. We need more information. So what we're going to do, let me just pull up some notes here. So what we're going to do is scene fractions. So what that means is that we have seen these fractions, and we're going to set these as ints. So, and we're going to get a count of 0. So for fraction in fractions, what we're going to have to do is take the greatest common denominator and divide it by the numerator and the denominator so that we can get a like a common pair of numerators and denominators so that we can say we have seen them. If you have a 5 and a 10 inside your scene, 1 and 1/2 is not going to pick that up. So what we're going to have to do is GCD equals GCD of fraction 0 and fraction 1, which is the numerator and denominator of those two numbers. Then the numerator is equal to the fraction of 0 divided by the GCD. And the denominator is equal to fraction of 1 divided by GCD. With that, we have the numerator and the denominator. That means we can get the fraction. This is going to be our key that we will be inserting into scene fractions. And also, at the same time, we'll get the counterpart too. Because we need to know, like, if the counterpart exists. If the counterpart exists, let's add that to our count. If it exists 2 times, let's add it twice. If it exists 3 times already, let's add it 3 times. So that means is we're going to set the count first of fractions of the counterpart. So you use the default dictionary, so we don't have to check if it's in there or not. I know it's a little faster if we do check, but we'll do this first. And scene fractions is the fraction is gonna plus equals 1. With that, we can return the count and we have our answer. Oh, runtime error. Right, math.gcd. So that is 58%. Now, if we do a if counterpart in scene fractions, then we purposely do this. If we check this, it's somehow much faster. I think the reason is because we don't have to go in. I mean, I guess accessing the value takes more time, and this brings down the time, but because we're only accessing the key, so only doing one thing rather than two things. Um, Anything else about this problem? Yeah, this problem required, what I learned the most about this particular problem is that it's a devil's in the details. You really have to think clearly about what you're trying to do, and don't give up when things are unclear. Just make sure that uh, you are very clear about what's the information that you are working with. And if it's clear, then you can solve it. So, right. If you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below.